Welcome to solverfy.
So this is essentially a diagram of what's going on. We can say that the net gravitational field will be equal to gravity to the right plus the gravity to the left. You may notice that if this angle is theta and this angle is theta, in the x direction, they're actually going to cancel out. So we actually don't have to find the x direction. In fact, here, because based on symmetry, we know that the x direction is going to cancel out, we can actually just simply find the magnitude of 1 in the magnitude of 1 in the y direction, and then multiply that by 2, given that we can say that g is simply equal to g right. Rather, we can say that the gravity on the right is equal to the y component of the gravity of the y will equal the y component on the gravity on the left. And we can say that the x component will be opposite of one another. So this is just based on symmetry so that we don't have to write so many terms. And at that point, we can just say that g is simply going to be equal to in this case, it'll be negative 2gm over x naught squared plus y naught squared cosine of theta times j hat. Now, I said negative because we're going down, and if we wanted to substitute for cosine of theta, we can say that g, the vector, the gravity vector is going to be equal to negative 2gm over x naught squared plus y naught squared times y divided by the square root of x naught squared plus y naught squared. And so, and again, j hat. And so this will equal negative 2gm y divided by x naught squared plus y naught squared to the 3/2 power times j hat. So this would be our final answer. And so for part B, when they're asking for the maximum acceleration due to gravity, we can say that g equals 2gmy divided by. So essentially, we're taking a relationship from part A, and we're saying dg with respect to time will equal 2gm. And then here is where we have to make the substitution. And let's say dg over dt equals 2gm. And then here it'll be x naught squared plus y naught squared to the 3/2 power minus y times 3 over 2 times x naught squared plus y naught squared to the 1/2 power times 2y. And this will be divided by x naught squared plus y squared to the 3rd power. Oh, my apologies, actually, these the subscript actually goes away. And so at this point, we can say that this is going to equal 0. So essentially, we took the derivative, we set it equal to 0, which is a bit hard considering we need to use the product rule. However, we need to use a derivation through a derivation of a fraction. And this will equal 0. Now we can set this equal to 0 and create a sort of quadratic and say that x naught squared plus y squared to the 3/2 power minus y 3/2. This will all equal 0. And so we can find that y max is going to equal x naught over radical 2 after some simple algebraic manipulation. And this is equaling 0.71 x naught. So rather, we can just say y max equals 0.71 x naught. So just keep this in mind, because when we want to find the maximum this would be the critical y where we are getting the maximum gravitational field. So G max would be equal to G, where y equals x naught over radical 2. And this is equaling 2gm, and then let's x naught over radical 2. And then for the denominator, it'll be x naught squared plus x naught over radical 2 squared to the 3/2 power. And so we find that G max is going to equal 0.77 gm over x naught squared. So this would be the formula for the maximum gravitational field. That is the end of the solution. Thank you for watching.